Chapter 8. Application. The costs of taxation. Taxes are often a source of heated political debate. In 1776, the anger of the American colonists over British taxes sparked the American Revolution. More than 2 centuries later, the American political parties continue to debate the proper size and shape of the tax system, yet no one would deny that some level of taxation is necessary. As Oliver Wendell Holmes Jr. said, "Taxes are what we pay for civilized society." Because taxation has such a major impact on the modern economy, we return to the topic several times throughout this book as we expand the set of tools we have at our disposal. We began our study of taxes in Chapter 6. There we saw how a tax on a good affects its price and the quantity sold, and how the forces of supply and demand divide the burden of a tax between buyers and sellers. In this chapter, we extend this analysis and look at how taxes affect welfare, the economic well-being of participants in a market. In other words, we see how the high price of civilized society can be. The effect of taxes on welfare might at first seem obvious. The government enacts taxes to raise revenue, and that revenue must come out of someone's pocket. As we saw in Chapter 6, both buyers and sellers are worse off when a good is taxed. A tax raises the price buyers pay and lowers the price sellers receive. Yet to understand more fully how taxes affect economic well-being, we must compare the reduced welfare of buyers and sellers to the amount of revenue the government raises. The tools of consumer and producer surplus allow us to make this comparison. Our analysis will show that the cost of taxes to buyers and sellers typically exceeds the revenue raised by government. 8-1. The deadweight loss of taxation. We begin by recalling one of the surprising lessons from Chapter 6. The impact of a tax on a market outcome is the same whether the tax is levied on buyers or sellers of a good. When a tax is levied on buyers, the demand curve shifts downward by the size of the tax. When it's levied on sellers, the supply curve shifts upward by that amount. In either case, when the tax is enacted, the price paid by buyers rises and the price received by sellers falls. In the end, the elasticities of supply and demand determine how the tax burden is distributed between producers and consumers. This distribution is the same regardless of how it is levied. Figure 1 shows these effects. To simplify our decision, this figure does not show a shift in either the supply or demand curve, although one curve must shift. When curve shifts depend on whether the tax is levied on sellers, the supply curve shifts, or buyers, the demand curve shifts. In this chapter, we can keep the analysis general and simplify the graphs by not bothering to show the shift. The key result for our purposes here is that the tax places a wedge between the price buyers pay and the price sellers receive. Because of this tax wedge, the quantity sold falls below the level that would be sold without a tax. In other words, a tax on a good causes the size of the market for the good to shrink. These results should be familiar from Chapter 6. 8-1A. How a tax affects market participants. Let's use the tools of welfare economics to measure the gains and losses from a tax on a good. To do this, we must take into account how the tax affects buyers, sellers, and the government. The benefit received by buyers in a market is measured by consumer surplus, the amount buyers are willing to pay for the good minus the amount they actually pay for it. The benefit received by sellers in a market is measured by the producer surplus, the amount sellers receive for the good minus their costs. These are precisely the measures of economic welfare we used in Chapter 7. What about the third interested party, the government? If T is the size of the tax and Q is the quantity of the goods sold, then the government gets total tax revenue of T times Q. It can use this tax revenue to provide services such as roads, police, and public education, or to help the needy. Therefore, to analyze how taxes affect economic well-being, we use the government's tax revenue to measure the public benefit from the tax. Keep in mind, however, that this benefit actually accrues not to the government, but to those on whom the revenue is spent. Figure 2 shows that the government's tax revenue is represented by the rectangle between the supply and demand curves. The height of this triangle is the size of the tax, and the width of the rectangle is the quantity of the goods sold, Q. Because a rectangle's area is its height times its width, this rectangle's area is T times Q, which equals the tax revenue. Welfare without a tax. To see how taxes affect welfare, we began by considering welfare before the government imposes a tax. Figure 3 shows the supply and demand diagram and marks the key areas with the letters A through F. Without a tax, the equilibrium price and quantity are found at the intersection of the supply and demand curves. The price is P1 and the quantity sold is Q1. Because the demand curve reflects buyers' willingness to pay, consumer surplus is the area between the demand curve and the price, A plus B plus C. Similarly, because the supply curve reflects seller's cost, producer surplus is the area between the supply curve and the price, D plus E plus F. In this case, because there is no tax, tax revenue equals 0. Total surplus, the sum of consumer and producer surplus, equals the area A plus B plus C plus D plus E plus F. In other words, as we saw in Chapter 7, total surplus is the area between the supply and demand curves up to the equilibrium quantity. The first column of the table in Figure 3 summarizes these conclusions. Welfare with a tax. Now consider welfare after the tax is enacted. The price paid by buyers rises from P1 to PB. So consumer surplus now equals only area A, the area below the demand curve and above the buyer's price. The price received by the sellers falls from P1 to PS. So producer surplus now equals only area F, the area above the supply curve and below the seller's price. The quantity sold falls from Q1 to Q2, and the government collects tax revenue to equal the area B plus D. To compute total surplus with the tax, we add consumer surplus, producer surplus, and tax revenue. Thus, we find that total surplus is area A plus B plus D plus F. The second column of the table summarizes these results. Changes in welfare. We can now see the effects of the tax by comparing welfare before and after the tax is enacted. The third column of the table in Figure 3 shows the changes. The tax causes consumer surplus to fall by the area B plus C and producer surplus to fall by the area D plus E. Tax revenue rises by the area B plus D. Not surprisingly, the tax makes buyers and sellers worse off and the government better off. The change in total welfare includes the change in consumer surplus, which is negative, the change in producer surplus, which is also negative, and the change in tax revenue, which is positive. When we add these three pieces together, we find that total surplus in the market falls by the area C plus E. Thus, the losses to buyers and sellers from a tax exceed the revenue raised by the government. The fall in total surplus that results when a tax or some other policy distorts a market outcome is called a deadweight loss. The area C plus E measures the size of the deadweight loss. To understand why taxes impose deadweight losses, recall one of the 10 principles of economics in Chapter 1. People respond to incentives. In Chapter 7, we saw that free markets normally allocate scarce resources efficiently, that is, in the absence of any tax. The equilibrium of supply and demand maximizes the total surplus of buyers and sellers in a market. When the government imposes a tax, it raises the price buyers pay and lowers the price sellers receive, giving buyers an incentive to consume less and sellers an incentive to produce less. As buyers and sellers respond to these incentives, the size of the market shrinks below its optimum, as shown in the figure by the movement Q1 to Q2. Thus, because taxes distort incentives, they cause markets to allocate resources inefficiently. 8-1B. Deadweight losses and the gains from trade. To get some further insight into why taxes result in deadweight losses, consider an example. Imagine that Joe cleans Jane's house each week for $100. The opportunity cost of Joe's time is $80, and the value of a clean house to Jane is $120. Thus, Joe and Jane each receive a $20 benefit from their deal. The total surplus of $40 measures the gains from trade in this particular transaction. Now suppose that the government levies a $50 tax on the providers of cleaning services. There is now no price that Jane can pay Joe that will leave both of them better off. The most Jane would be willing to pay is $120, but then Joe would be left with only $70 after paying the tax, which is less than his $80 opportunity cost. Conversely, for Joe to receive his opportunity cost of $80, Jane would need to pay $130, which is above the $120 value she places on a clean house. As a result, Jane and Joe cancel their arrangement. Joe goes without the income, and Jane lives in a dirtier house. The tax has made Joe and Jane worse off by a total of $40 because they have each lost $20 of surplus. But note that the government collects no revenue from Joe and Jane because they decide to cancel their arrangement. The $40 is pure deadweight loss. It's a loss to buyers and sellers in a market that is not offset by an increase in government revenue. From this example, we can see the ultimate source of deadweight losses. Taxes cause deadweight losses because they prevent buyers and sellers from realizing some of the gains from trade. The area of the triangle between supply and demand curves created by the tax wedge, area C plus E in Figure 3, measures these losses. This conclusion can be seen more easily in Figure 4 by recalling that the demand curve reflects the value of the good to consumers and that the supply curve reflects the costs of producers. When the tax raises the price buyers pay to PB and lowers the price sellers receive to PS. The marginal buyers and sellers leave the market, so the quantity sold falls from Q1 to Q2. Yet, as the figure shows, the value of the good to these buyers still exceeds the cost to these sellers. At every quantity between Q1 and Q2, the situation is the same as in our example with Joe and Jane. The gains from trade, the difference between buyers' value and sellers' costs, are less than the tax. As a result, these trades are not made once the tax is imposed. The deadweight loss is the surplus that is lost because the tax discourages these mutually advantageous trades. 8-2. The determinants of deadweight loss. What determines whether the deadweight loss from a tax is large or small? The answer is the price elasticities of supply and demand, which measure how much the quantity supplied and the quantity demanded respond to changes in the price. Let's consider first how the elasticity of supply affects the supply of deadweight loss. In the top two panels of Figure 5, the demand curve and the size of the tax are the same. The only difference in these figures is the elasticity of the supply curve. In panel A, the supply curve is relatively inelastic. Quantity supplied responds only slightly to changes in the price. In panel B, the supply curve is relatively elastic. Quantity supplied responds substantially to the changes in the price. Notice that deadweight loss, the area of the triangle between the supply and demand curves, is larger when the supply curve is more elastic. Similarly, the bottom two panels of Figure 5 show how the elasticity of demand affects the size of the deadweight loss. Here, the supply curve and the size of the tax are held constant. In panel C, the demand curve is relatively inelastic and the deadweight loss is small. In panel D, the demand curve is more elastic and the deadweight loss from the tax is larger. The lesson from this figure is apparent. A tax has a deadweight loss because it induces buyers and sellers to change their behavior. The tax raises the price paid by buyers so they consume less. At the same time, the tax lowers the price received by sellers so they produce less. Because these changes in behavior, the equilibrium quantity in the market shrinks below the optimal quantity. The more responsive buyers and sellers are to changes in the price, the more equilibrium quantity shrinks. Hence, the greater elasticities of supply and demand, the greater the deadweight loss of a tax. 8-3. Deadweight loss and tax revenue as taxes vary. Taxes rarely stay the same for long periods of time. Policymakers in local, state, and federal governments are always considering raising one tax or lowering another. Here we consider what happens to the deadweight loss in tax revenue when the size of the tax changes. Figure 6 shows the effects of a small, medium, and large tax, holding constant the market supply and demand curves. The deadweight loss, the reduction in total surplus that results when the tax reduces the size of a market below the optimum, equals the area of the triangle between the supply and demand curves. For the small tax in panel A, the area of the deadweight loss triangle is quite small, but as the size of a tax rises in panels B and C, the deadweight loss grows larger and larger. Indeed, the deadweight loss of a tax rises even more rapidly than the size of the tax. This occurs because the deadweight loss is the area of a triangle and the area of the tax this occurs because the deadweight loss is the area of a triangle, and the area of a triangle depends on the square of its size. If we double the size of a tax, for instance, the base and the height of the triangle double, so the deadweight loss rises by a factor of 4. If we triple the size of the tax, the base and height triple, so the deadweight loss rises by a factor of 9. The government's tax revenue is the size of the tax times the amount of the goods sold. As the first three panels of Figure 6 show, tax revenue equals the area of the rectangle between the supply and demand curves. For the small tax in panel A, the tax revenue is small. As for the size of a tax increases from panel A to panel B, tax revenue grows. But as the size of the tax increases further from panel B to panel C, tax revenue falls because the higher tax drastically reduces the size of the market. For a very large tax, no revenue would be raised because people would stop buying and selling the good altogether. The last two panels of Figure 6 summarize those results. In panel D, we see that the size of a tax increases, its deadweight loss quickly gets larger. By contrast, panel E shows that tax revenue first rises with the size of the tax, but as the tax increases further, the market shrinks so much that the tax revenue starts to fall. (8-4) Conclusion. In this chapter, we have discussed the tools developed in the previous chapter to further our understanding of taxes. One of the 10 principles of economics discussed in Chapter 1 is that markets are usually a good way to organize economic activity. In Chapter 7, we use the concepts of producer and consumer surplus to make this principle more precise. Here we have seen that when the government imposes taxes on buyers or sellers of a good, society loses some of the benefits of market efficiency. Taxes are costly to market participants not only because taxes transfer resources from those participants to the government, but also because they alter incentives and distort market outcomes. The analysis presented here and in Chapter 6 should give you a good basis for understanding the economic impact of taxes, but this is not the end of the story. Microeconomists study how best to design a tax system, including how to strike the right balance between equality and efficiency. Macroeconomists study how taxes influence the overall economy and how policymakers can use the tax system to stabilize economic activity and to achieve more rapid economic growth. So as you continue your study of economics, don't be surprised when the subject of taxation comes up yet again.